The Nancy Grace Roman and James Webb space telescopes have very different approaches to studying the universe. Roman has an extremely wide view to capture as much of the cosmos as possible. Webb will peer deeper than any telescope before it to see more detail and farther into the past. These contrasts enable different science and help us answer separate questions about the universe. Beginning with its beginning. Webb will see galaxies that are extremely far away, whose light was emitted when the universe was very young. It will reveal an early universe that scientists have only explored through calculations. We have very little information about the cosmos' infancy, and Webb will help us fill in many of the gaps by making direct observations of galaxies as far into the past as physically possible. Roman, on the other hand, will use the power of its wide sky coverage to survey massive regions of space, documenting significant portions of the universe through its adolescent and early adult years. Not only does Roman have a field of view 100 times larger than Webb's, but its compact and rigid design makes it more nimble, able to quickly repoint that wide view to survey large regions through a process called tiling. Roman will be able to survey thousands of square degrees of sky during its primary mission, enabling studies that were never possible before. Only by studying millions of galaxies can scientists begin to determine the behavior of the universe as a whole, like its large-scale structure and how it has changed over time. Dark matter and dark energy are both large presences in the universe that are only detectable through their effects on normal matter. The brightnesses of faraway supernovae work to measure the distances of galaxies and how dark energy is pushing them apart. The precise shapes of galaxies serve as a way to study the dark matter around them, but these features must be measured very accurately to be usable. Roman's hardware is particularly precise and well understood, so the data it collects is especially good for the statistical analysis required, giving scientists a holistic view of how dark matter and dark energy exist and affect the visible universe. Previous great observatories, Hubble, Chandra, Spitzer, and Compton, greatly expanded our understanding of the universe. Some of it was in ways that scientists and engineers had anticipated and designed the telescopes for. But many other discoveries were unanticipated, as the great observatories revealed new aspects of the universe and scientists discovered creative ways to use these powerful tools. The same will be true of both Roman and Webb. We can anticipate some of what they will show us, but many of the most exciting discoveries are the ones we can't predict.